Okay, so here we are on the flip side of the B. I will be making an aftermath video that talks about what a game plan is for those of you who plan to take the test in 2025 and kind of a recap of this competition season. That should come out shortly after the solutions that I get out tonight will come out. Probably by the end of the week you will get that video. What do I think? The first 5 problems, by the way, on both tests are the same, which is the first time I've ever seen that before as well. I felt like the easier ones on the B were really easy, especially if you took the small notebook class. There were so many problems that you could blitz in 30 seconds to a minute with concepts that were in there. The A test honestly did not have as many of those, and I felt like the harder questions were harder. There were several where the reasoning, you had to take a lot of time to be sure you weren't making a mistake because you had like, is it 2, is it 3, is it 4 solutions for like the X, Y, Z ordered triple. And so those kinds of questions took a little bit more time, but I didn't feel there was as many of the quote unquote easier questions that took more time like they did in the A. On the A, the easier questions actually had significant time loss, in my opinion. So let's go ahead and get started and get a look at this. As far as the cutoffs go, what do I think? Hard to say. The cutoffs on the B tend to be a little bit higher than the A, and the predominant theory in the community is that students taking the B tend to be more serious. A lot of the high schools in the nation only offer one test, and that's usually the A test. And so schools and students that are less serious about the competition, they only take one test, would usually be on the A test if they did, which makes the scores a little bit, is a lot more lower scores, and so your percentage is going to be, the cutoff will be lower for that. And so more students take the A test than the B test as well. And so then the seasoned ones take the B test and they get higher scores. So now your top 5, 6, 7%, whatever it's going to be, is a higher number. So could the B test get as high as 105 for the 10B? I think it could. Could it get lower still, like 100.5? Sure. I don't know. It's hard for me to guess what exactly the cutoff will be. It depends on how many people got flummoxed by problems that had quite a bit of time drain action on them. For the 12B, I felt maybe like it was actually easier than the 12A. I felt like there was, again, a lot of problems that had significant time savings available if you recognize the mechanism at play. There was also several that, like, I started down one path, went a little ways down it, and then said, you know what, let's go back and look at this again and revisit it as a different way. Especially in algebraic manipulation type problems, you'll see that maybe the first or second path you take wasn't the best and the third path was. So it depends on how many people took those false paths, lost time, and therefore had less time to answer questions later in the test. Could the cutoff for the B, 12B get up to 91.5, 93? It's possible. I don't know. It could be lower as well, sub 90. It's hard for me to guess. Don't take my guesses on that with any accuracy necessarily. I think my A guesses would be a lot more accurate, but the B test, I don't know, harder to say. Again, your safe scores are probably a 105 on the 10B, and for the 12B, maybe 106.5 though. 12B would probably be a safe score of 93 with the expected cutoff actually lower than that. So those are my guesses. Maybe I'm wrong. We'll see. Let's go ahead and get started. Again, did notice that none of the things I predicted in the Monday class, the Monday video, were actually on the test. Those were guesses. Like, they weren't predictions. They were guesses. It was maybe this could happen. If it was going to happen, these were the problems that would probably be represented as repeated concepts, basically thematic concepts that carry over from the A test to the B test. They don't do that all the time, but usually if they did, it would be some sort of an anomalistic type problem, and those two problems fit that category. Unfortunately, it did not pay off as a gamble to study them, but hey, at least you got better at transformations, right? So let's go over these, starting from the 10B problem 1. Again, this problem, significantly less time than the number 1 on the A test. In a long line of people arranged left to right, the 1,013th person from the left is also the 1,010th person from the right. So it's 1,013 plus 1,009. Why this? Because if you're, what I did to be convinced this is what it was, I just made a sample case. Like if I put people in a line and then I put 4, 5, 6, this is the 4th person from the left, but that means there's only 3 person to the right of it, and it's the 3rd person from the left. I'm sorry, from the right, it's the 4th person. From the left, it's the 3rd. You don't count that person twice. But when counting from the left, starting at 1, you definitely would have 3, and then you would have to add not 4, even though he was the 4th from the right, but 3. What is this doing? It's convincing yourself that your reasoning is valid. And so I did that. Now, it doesn't take long to do something like that. You feel a lot more convinced this is what it will be, and the answer will be 2022. But really, I mean, this is just a safety thing to be sure because it felt so easy, so quick. Are you sure you're doing it right? Maybe there's something you're not considering. Nope, that's a great way. This made me convinced. Moved on to problem 2, as we'll do right now. Okay, so this is exactly the kind of problem I'm talking about that you could blitz in like 15 seconds if you are comfortable with factorials. Let's get a look. You can see 7 factorial as part of both of these, so you might as well factor it out immediately, giving you 10 times 9 times 8 minus 6 factorial. Now what's this? 72 times 10, 720. 6 factorial, 720. So I have that memorized. You probably should too. Have your first 6 factorials or 7 factorial. 7 factorial is 5,040. Above that, I don't remember it, but I mean, you can do it pretty quick, just 40,320. So it's not hard to derive from this point going forward. Don't have 9 factorial off the top of my head though, but you can see that it's just brutally quick. Like it was just a quick answer of 0 because you get this 0 in the middle. And I don't know what else to say about it. Let's get on to problem 3. So this question number 3 for both tests, it starts off with a very standard beginning. In fact, this is a small notebook concept. I'm not sure I covered it in the class that I did because it's kind of an AMC 8 level idea. In general, if you have x less than c or equal to either way, this is an and problem, and you just go x is less than c and greater than negative c. And that's exactly how you'll handle that. So we're going to end up doing that here. And so let's go ahead and get started with that. You're going to have 2x less than or equal to 7 pi and greater than or equal to negative 7 pi. Now you're going to divide by 2, so you're going to have negative 7 over 2 pi less than or equal to x greater than or equal to 7 over 2 pi. Now, how you went about it from this point, there's a little bit of variation on what you could do or what you thought might work. Obviously, we're going to have the same number, negative, positive, and you're going to have the 0 in between. The question is, what should we use for pi? Should we use 22 over 7? I am curious what happens right now. I haven't actually checked yet. If you use 22 over 7, you get 11 values. It comes out to exactly negative 11. 22 over 7 is a rough estimate of pi sometimes used. And so you'd have 11 here, 11 there, and you'd end up with 23. And clearly we don't have that. So, I mean, I guess you could probably use that and say, well, since this is a rough estimate and it's over by 2, the answer must be 21. Probably not a bad thought. But I don't know. It depends on how quickly you drew the right conclusions you needed to draw to act on it. If you tried using 3.14, that was even really close as well. So you say 3.14 times 7, or you could do 35, 3.5 basically, and go ahead and multiply it out. You do 5 times 4 is 20, 0, 2, 5, 7, 15, a 0 here, and 942 here. And you've got 0, 9, 9, 10 with 3 decimal places. And so it's 10.990, but then you get kind of haunted because you're like, well, what if I had put like the 159 or something? Would I be able to get enough that you would eclipse this value and get to 11? But again, it's not available as an option. So even if you went over 11, that's not possible. You'd have 11 negatives, 11 positives, and then you'd have 0 in the middle as well for a total of 23. Not up there. Gonna have to be 21 at this point. You can be assured that this will be there. You'll have 10 negatives, 10 positives, and the 0 in the middle for a total of 21. But if you weren't sure and you added this and you multiplied, again, people had an opportunity to lose additional time here, but it just depends on how many people did that, how many were slowed down and lost that time. Let's get to problem 4. Okay, so now this question has a lot of concepts in it that you might be familiar with if you're fairly experienced. I hope you caught them. Let's get started in looking at it. Balls numbered, this is problem number 4 from both tests. Balls numbered 1, 2, 3, and so on are deposited in 5 bins labeled A, B, C, D, and E using the following procedure. Ball 1 is deposited in bin A, 2, and 3. Okay, so at that point when you're reading, you should probably make yourself a little list about what's going on so that you can keep track. 1 is here, 2 and 3 are here. The next 3 balls are deposited in C, so you've got 4, 5, 6, and the next 4 in D, and so on, cycling back to bin A after the balls are deposited in bin E. So right now, at this point, you should be thinking about how if I added 1 plus 2, I would get the last ball that was put in bin B. And if I did 1 plus 2 plus 3, I would get 6. We call these numbers, by the way, the result of these 1, 3, 6, 10, 15, 21, 28. I know about that many off the top of my head. We call them triangular numbers. So why are they called that? The first one, not so obvious why it would be called that. It's just 1. But then when you put the next 2, which also could be the word therefore in Boolean logic symbols, therefore, so you get triangle though is the most important thing. Now when you add a row of 3, your equilateral looking triangle is starting to expand out. And when you put a row of 4, you're going to get a triangle continued on. And so that's why they're called that, the sum of 1, 2, 3, and 4, and so on. And so you'll have, this is 10, you add 5, you're at 15, you add 6, you add 7. And so that tells you kind of your strategy on the problem. Once you recognize that that's what's going on, that's the underlying mechanism that the problem is built on, the infrastructure, if you will, then go ahead and read the for example just in case. Again, 22 to 28, which is the sum of 1 to 7. Notice that when you go, you're ending at 1 and you sum up to 2, you're in bin B. That's where you're at, okay? You sum to 3, you sum to 4, you sum to 5, you sum to 6, you sum to 7. So you can see what is B. It's like, it's got a remainder of 2 when divided by 5, remainders of 3 when divided by 5, 4 when divided by 5, and 5 it goes in evenly for the E column. So the E, when you put the last one in there on the next row, it should be the sum of the numbers 1 to 10, which is 55. Okay, some of the numbers 1 to 9 is 45. A lot of these numbers are quite well memorized by the community, especially the ones that have been studying for a couple of years. So how do you capitalize on it? Let's get to that. In which bin is ball 2024 deposited? Okay, so if we want to go, we're basically adding up the numbers from 1 to n, and we would like it to be close to 2024. Okay, it won't be exactly equal to it because 2024 might not be at the end of adding a number. Like, you put 3 in here and 4 in here. Maybe it wasn't the last one you put in. You don't know that information at this time. So this also has a formula, the sum of the series from 1 to n. It's arithmetic. You could also just memorize the formula. I like to memorize this one, n times n plus 1 over 2. And if I say that's approximately 2024, we'll multiply by 2 to get 4048. And now we want to know what this is. Your ability to estimate quickly using whatever strategy you can is critical on the test so that you don't have to do a bunch of remedial calculations. So for example, I might look at this and say it's approximately n squared. And if I square 50, I'm at 2,500. So that's not even close. If I square 60 instead, I'll get 3,600. Getting closer, 70 squared, 4,900 is way too big. This is too low. We're probably somewhere in the middle. You can use the 5s trick to say that 65 squared is 6 times 7 with a 25. You're going to get 4225, also too big. So then at that point you go, okay, maybe it's like around 63. And so we try something like plugging in 63, and you're going to get 63 times 64 over 2. So, if you go back, plug it in to see if you get close to 2024. We'll do 2 goes into here 32 times. I'm going to say 63 times 30 plus 2, and I'm going to get 189 with a 0. And then 2 63s, which is 126. That's going to be, take 110 of it to get to 2,000. And then you've got 16 more. So you're at 2016 when you've gotten up to n is 63. So you're not quite there yet. You're going to put, in the next one, you're going to put a bunch more, like 64, into the last bin that you put it in. And since 63 is remainder 3, you're in column 3 right now. But when you add the 8 more to get to 2024, you're going to be in column D. Okay, so the answer will be D. I hope that made sense. If not, leave a comment. I will try to explain better than that. I abandoned the 40-48 at this point and just went to right here to divide by 2 because I thought the calculation would be easier than 63 times 64. Just made a quick decision there. So that's it for this one. You could take a little bit of time on this because depending on how quickly you guess where you're at, and if you use the n squared estimation. If you're not using estimations, add it to your arsenal. Again, critical way to save some time. Let's get to problem 5. By the way, in that last problem, problem 4, both of those concepts, the sum of the numbers from 1 to n being n times n plus 1 over 2, and the idea of triangular numbers should both be in your small notebook. If you don't know what I'm talking about, I will link the video, The Small Notebook Justified and Explained. In fact, I'll point to it. It'll probably be over there on the screen with a little thing that you can click to watch that video. It's basically key ideas and concepts and things like that. So let's go ahead and look at another one that should also be in there. It's more of an AMC 8 level small notebook concept. The students that have been around for a while are very aware of it. It's very common knowledge. And so in the following expression, Melanie changed some of the plus signs to minus signs. So you have this expression. Now what is it? It's the sum of the odd numbers. And the sum of the odd numbers is which odd number it is squared, like the nth odd number. For example, if you do 1 plus 3 plus 5, that's 9. But notice that's the third odd number, and 3 squared is 9. So if I added 7, I would go to 16, and that's of course the fourth odd number, and 4 squared is 16, and so on. So when you go out to 2n minus 1, which is the nth term, that's equal to n squared. That should be in your small notebook as well if it's not already. So this is, what odd number is this? I don't use the fact that 2n minus 1 to calculate this. I don't think of it that way. Just find the next even term, like 100, and ask yourself what even that is. Well, it's the 50th even, because 100 over 2 is 50, and the 50th odd comes right before the 50th even. So that will always work, by the way. If you have, like, you're at, I don't know, 37, you want to know what odd number it is. Just go to 38, divide by 2, get 19. It's the 19th even, so it's the 19th odd. And so once you see that often enough, you get used to it. So here we go. She changes some of the plus signs to minus signs. When the new expression was evaluated, it was negative. So when she did that, changing this, it changes it to negative overall, the sum of the overall expression. What is the least number of plus signs that Melanie could have changed to minus signs? So obviously if she wants to do the least number, the biggest one should be the one she changes to negative to make it negative. We do get some optimization or min-maxing, whatever you want to call that kind of idea, where you're looking for the least number that you could change. So the first thing I'm going to do is just say, what's the sum of this? It's 2,500. Now, rather than think about the ones on the backside, which are going to be hard to count, we'll just count the ones in the front. When the ones in the front first drop below 1250, then that's it. Because if the positive part is less than 1250, the negative part must be greater than 1250 and therefore become negative. And so when you look at it, you're like, well, you want to change these ones on the backside. Why guess and check when you've got answers to guess and check with? Don't just randomly guess something. Go ahead and pick something from the answers. And for me, I started here. Why? Because it's easier to work with. If I take 15 numbers off the back of the 50 odds that you have, you'll have 35 odds in front. And so you're going to say 35 squared. And again, this is the fives trick, another small notebook concept. You take the fives trick is where you ignore the 5, you take the tens place, and you multiply it by the number after it in the number line, which is 12, and then you reattach 25. This works for all numbers that end in 5. And so like, for example, 75 squared would be 7 times 8, 56, and then you attach 25. Try it for yourself. It even works for 3 digits as well. 115 squared, 132, 25, 11 times 12 with 25 on the end. So you're going to get 1225. And what did we say? We said we need the square of the number, the odd number. Which odd? Like the nth odd, not the specific number itself. It's the 35th odd. If I sum up to the first 35, I will be here. And that positive sum is less than 1250. So this accomplishes the task. But the question is it the least number that you could use? And so what we want to know is, could I go down to 14 change to negative? What that would do is give us the first 36 odds, and you'd have to check what 36 squared is. Of course, if you took my class, you should know the difference in consecutive squares is the sum of their bases. So between 1225 and the next perfect square up from it, you're just going to add 71, which is the sum of 35 and 36. So this is 1296. Now, you don't even have to add it. You can just look at it and say, I'm only 25 below 1250 right now. If I'm adding 71, I'm going to go over. The exact number doesn't really matter. It's that you go over 1250 with your positive sum, which for us is a bad result, and that means this is the answer. Using the answers to help you reason is not weak. You should be doing it a lot. It's no holds barred on the test. Whatever you can think of, whatever gets you the answer the fastest, don't worry if it's neat, clean, pretty, if your math teacher would love it or not. You go as quick as you can with whatever method you can. Okay? Let's go ahead and get to the next set of rapid fire for each of the 10B and the 12B.